Okay, just gonna do some more. Gonna do another one of these and maybe just do some inequality stuff and just everybody has to do inequality stuff to a degree. Junior cert, leaving cert, ordinary and honors. So I just thought I'd do one, kind of cover a few basic things, just so that I always find in the exam if there's something in there that you kind of have that you can do, and it's nice. And I don't want to say simple because obviously people struggle with this. Sorry if I made noise there. But just gonna have a look through it and just see. I'm gonna show you first on the left here. I'm gonna show you just a couple of things, and these were both in junior certs where it just inequality symbols will show up. If you remember the inequalities work, I'm gonna describe them as kind of like crocodiles, where the crocodile will try to go towards, will go be eating the bigger number, right? So that's how we will be describing it. I don't know. There you go. Crocodile. Right, so that's the idea that the crocodile is eating the bigger number. So 1 would be less than 3, 7 will be greater than 2. If we say x is less than 6, it means that no matter what number you put in place of the x, it has to fit that idea where the crocodile wouldn't want to be eating it, it would be wanting to eat the 6 instead. So it would mean that any number you put in place of the x there has to be smaller than the 6, so that it would make sense that if you did sub it in, it would make sense. So it could be a 5, a 4, a 3, a 2, a 1, a 0, a -1, a -2. It could be 5.2. We're going to see a few more of those later on, depending on what they ask for. You have to limit your answers depending on what they actually ask for, right? But we'll see that when we get onto it. And also don't forget, if it is x is less than or equal to 6, if it has that little line at the bottom, it means it's an inequality and an equality symbol put together. It's if any of you ever do coding, it's kind of written. Now I don't know, they wouldn't do this actually now that I think about it, but it's kind of like that idea, right? Where you do x is less than or equal to 6. So in this example, it could be 5 or 4 or 3 or 2 or 1. In this example here, it can be 6 or 5 or 4 or 3 or 2 or 1. You can include 6 now as well using that, right? It just means both of them can apply. It can be a crocodile, it can be an equals, it could be either, so we account for both. Now this was in the 2023 junior cert, where it talks about a car that will show you the temperature, but obviously if you ever see a temperature like that, it's never going to show you like it's 17.6 degrees or 17.9. I thought that was a weird question, but they wanted to write down 3 possible values of the actual temperature, given that the car rounds it correct to the nearest whole number. I thought that was going to turn into a line. So what that means is, yeah, correct the nearest whole number there. So what that means is it might not be exactly 18 degrees. It could be 17.6, it could be 18.2, it could be 18.0 if you want, or 18. Those are all possible values. One of them could be 17.9223072. Could be. Anything would have worked for there, as long as when you round it, it goes to 18. And when you round it, don't forget that if it's 7, so 749 would not round up, or 17.49 would not round up to 18. It would round down to just stay as 17. And I was going to say 0.0, but just 17, because if it's 5 or higher, if this number is 5 or higher, it goes up. If it's 4 or less, it goes down. And because it was 4 or less, it would go down to just 17. So just to talk about this part here then, because this is the bit I wanted to do, I had to give kind of a bit of a starter to it, which I know had nothing to do with inequalities, I know that. Let T represent the actual temperature at a given time. So that's just kind of saying, like, T is the concept of what the real temperature is. If I say to you, oh, what is T right now, you would have to check what temperature it is right now, and you would tell me what that number is. But if I ask you in 5 minutes, it might have changed. So that's why we use the letter T instead of like the actual number, because we can't just say, oh, well, it is 15 degrees, because it might not be 15 degrees. So we'd say the temperature is T, and then whatever the temperature is, you put it in instead of T at that time, right? So what they're saying here is fill in the missing values in the inequality in T below to show the range of possible values of T when she was going to work. So it's the idea that the car was telling her it was 18 degrees, and we put down 3 suitable answers. It says, basically, it's just kind of saying how far can it go either side of the 18 before it stops making sense? So for example, once it goes into the 17.49, it does not make sense. So where is the cutoff point before it won't round to 18, before it start rounding to 17 or 19 instead? So we're going to look at it in two ways. We're going to look at it kind of like the left hand side like this, and then we're going to look at the right hand side afterwards. But what I'm going to do is I'm going to say the temperature, in order for it to round up to 18, the temperature would at least have to be 17. I've messed that up ever so slightly, but bear with me. 17.5, because what you're saying is as long as it's 17.5, as long as the T, right, is 17.5 or bigger, because it's the equals and the inequality, right? So it means it can be 17.5 or T can be bigger than 17.5. So what that means is it could be 17.5 or 17.6 or 17.7 or 17.8 all the way up to infinity, right? If I wrote 17.5 is less than or equal to T, I'm saying T could be 17.5 or T could be 17.6 or T could be 17.7. And the reason why in the question this makes sense is because you'll notice all of these numbers, if we rounded them, would round to 18. All of these would, if you round them to the nearest whole number, would round to 18. Now the problem you're going to see though, if I keep going, because this is annoying, but I felt like I need to do it. If you kept going, you would eventually get to 18.5 and beyond, right? You just keep going, but 18.5 is actually no good to us, because if you get to 18.5, because the number is 5 or higher, it would actually round up to 19, which we don't want. We want it to round up to 18. So that means that we can't just say, oh, as long as it's bigger than 17.5 or equal to 17.5, it's okay. We have to do this right-hand side now as well, which is kind of saying, where's the upper limit? Where can we go up to until it stops making sense? And you notice we can go up until 18.5. Now, there's a bit of shenanigans here, because you'll notice there's a little equals here, but there's not here. And that makes sense, because it can be 17.5, because if it was 17.5, according to how rounding works, that would have to round up to 18. But if it was 18.5, the way rounding works, that would have to round up to 19. So we can't actually use 18.5, and that's why there's no little equals there, because that would not work in place of T. If I said to you, what time is it, or what temperature is it, and you said 18.5, the car, computer, or whatever would round that to 19. So we can't use it. That's why there's no little equals next to the, in between the T and the 18.5. So what we're doing is we're saying that as long as T is in between 17.5 or 18 and 18.5, and it can also include the 17.5 itself, then the car will round it to 18. I wouldn't really be too worried about the actual maths of it for what I'm trying to do here. I suppose obviously you should try understand it as best you can. But the idea I was trying to convey here is the idea of in the inequalities can show up just as like an idea more so than actual a mathematical question to do. So here the idea was, as long as you pick a value for T that's in between 17.5 and 18.5, of which you can also actually include 17.5 but not 18.5, then it would suit what the question asked, and it would round up to 18. And that's what, sometimes they will just use the crocodiles like that as bounds. That's why I just wanted to introduce this here. The rounding thing, I might do rounding it on its own, because people just cannot round nowadays. But the whole point was I wanted to show you how inequalities might just show up as kind of like a concept, as an idea, as I said. And it's just kind of saying, oh, well, T has to be in between these two numbers for the 18 to make sense. The little equals being that we can include 17.5, because if you round that, it would be 18, not there for the 18.5. So yeah, as long as you pick a number for T that's in between these two, that question would work, right? I'm going to harp on about that too much, but I was just trying to show you what the inequalities were. You'll notice it also shows up in these questions where you have to draw graphs of functions, because it says draw the following two functions in the domain -2, less than or equal to x, less than or equal to 2. So what that means is, again, it just means that you have to be able to put a number in place of x that both of those make sense. And it needs to make sense in a way that if you were to cover up the right-hand side, that this would make sense. So you need to make sure that if whatever number you put in for x, it's greater than or equal to -2. So that could be -2 or -1 or 0 or 1 or 2 or 3 or 4 or 5 or 6 or 7. But if you covered up this side, it also has to make sense. So it means whatever number you put in for x has to be less than or equal to 2. So that would be 2 or 1 or 0 or -1 or -2 or -3 or -4. but it has to make sense for both of them. So you'll notice the only numbers in both of those lists that I mentioned would be -2, -1, 0, 1, and 2, because they make sense both ways. No matter which one you cover up, they make sense. And that's just what I'm saying. Basically, make sure on your graph it only goes on these numbers on the x-axis, because don't forget the x-axis is what they mean when they put in the letter x there. So yeah, that just means that. It's normally it's done for you guys nowadays. They'll give you the graph like here and here. You'll notice they'll put the x-axis out and they put the -2 to the 2 on there. Don't forget though, normally if you would do this, you would just go to table mode on your calculator where you get fx equals, you write in 10x minus 4x squared, where the x is like alpha and then the right bracket. I'm not going to really get into that just now. I just want to kind of highlight that. And the idea is normally when you do that, you'd end up with start with the calculator most people have now at the moment. I know the other one is new, so I don't really know. I can't really tell you what's on the new ones, to be honest. But start, end, and step are normally what you would get after you put the function in, after you put the fx in. Your start is this number, so -2. Your end is this number, so 2, and your step is, for this is going to be 1, because you notice it makes sense that the numbers go up by 1 each time. There might be ones that I've seen. There might be ones that I've seen where what they do is they'll have the x-axis and they'll say, instead of -2 and 2 here, they might say like 0 less than or equal to x is less than or equal to 800. And what you'd have on here is like 0, 800 here. But then if that was the case, you'd want to change your step to 100. Now, obviously, the start and the end would have to change as well. They'd have to change from 0, or you'd have to change to 0 and 800, but the step would have to be 100, because then that would make sense too, right? But that's the idea. And then you go up by hundreds each time instead. I'm not going to do it all. So that's the idea. I'm not going to do that. I'll probably do something else for that. But that's just, again, another place where inequalities can show up, and I just scare the bejesus out of everybody. So I'm actually going to look at these ones now, I think. No, I'm not. I'm going to look at these ones. I think this question was actually done in a weird way where it's good to teach from, but it's not actually really good for doing. Like, it wasn't nice for people to actually do in their Leaving Cert, and this was in a Leaving Cert ordinary level question. However, it applies to everybody. It just so happens that it fit. So it says, put x is less than or equal to 2.8 on the number line 3 different times for 3 different lists. This one is saying that x has to be a part of the OR numbers. This says x has to be a part of the z numbers, and this said x has to be part of the n numbers. The OR stands for real, the z stands for integers, and the n stands for natural. They're on page 23 of your log tables. If you go there, you'll notice that you have the n is first. I've done that the wrong way around, but it doesn't matter. And it says, it does not say 0. I take that back wholeheartedly. That was a rookie mistake. It says n is 1, 2, 3, 4. And then there's a ... but that just means like so on. Then the z would be, I didn't give myself a lot of room here. It's ... then -2, we'll say -1, 0, 1, 2, ... The ... dot's either end, meaning that it goes infinitely in both directions. So this could keep going through all the minus numbers, and this will keep going through all the positive ones. Now for OR, it doesn't say anything, but that's because for OR, as far as you guys are concerned, it's everything. Everything. So you'll notice that the first one is just all the positive whole numbers. The second one is just all the whole numbers, the positives, the negatives, and the 0. Don't forget, because 0 is neither positive or negative. And OR is everything, so that means it's all the positives, it's all the negatives, it's 0, it's whole numbers, it's decimals, it's fractions, it's pies, it's square roots, it's all sorts of shit. There's also a fourth one that you guys don't really talk about too much, and it's Q. And Q is just everything that can be made into a fraction. But again, that doesn't really come up here. I just thought I'd mention it because people will say, but what about the thing? And there's also another one down the very bottom, but that's irrelevant too. That's for complex numbers. So you might think, oh, this is the same question 3 times, but because of the different letters they use, right, the different things, we're going to have to use different answers. So I'm actually going to weirdly start at the bottom because that's the like more basic one. N means it can only be positive whole numbers. It says, give me numbers that I can put in place of x that the number would be less than or equal to 2.8, but still be a positive whole number. So if I look at here, I can put in a 1, because 1 less than or equal to 2.8, that makes sense, that's fine. 2 is less than or equal to 2.8, that makes sense, that's fine. 3 is less than or equal to 2.8. That is no bueno, so we can't do it. And we literally just put a dot on the 1 and the 2. Because those are the only two suitable answers. They're the only ones that are both in the N, the list of natural numbers, that's what that's called, but also fit the inequality there, right? If we were to go up here, because it's x is an element of z, we can have the 2 and the 1, but not the 3. So we have everything from this list, but we also can do 0 is less than 2.8, that's fine. We can do -1 is less than or equal to 2.8, that's fine. And you notice that would just keep going forever, because there's no way that you're ever going to go down to a minus number that is not less than or equal to 2.8. So you literally just put dots on the 2 and the 1 like from before, but because z includes the zeros and the negatives, we can also put a dot on here and here and here and here and here, and that would be that one done. Now the thing is, neither of those included decimals or fractions, so that's why you'll notice there's gaps in between, like in between here and here there are nothing on, there's no dots, there's no lines, there's no anything in the gaps in between them, because that like in here is like 2.6 or -1.6, sorry, I was doing it the other way around. -1.6, you can't use that because that's not in z doesn't let you use decimals. Here it's plus 1.5, you can't use that because that's not in n doesn't let you use decimals. So you literally just put the dots on, if it says n or z, put the dots on the numbers. Or, because it means everything, that means you have to put a dot on every number in between. So it's going to be like all of these except the 1.5 we can include, and the 0.8 we can include, and the 0.12 we can include, and the -0.9 we can include, and the -1.9999999 we can include. We can include all the way up to the 2.8. So instead of drawing a dot on every single one of those, when we do or, that's when we do the line. I know you're all probably shouting, oh, the line, I remember the line, do the line, why isn't it on the line yet? That's because it's here. It was a bit shady because they didn't put in 2.8 for you. You had to do that yourself. Bit nasty, but either way, what we would do is now for or, what we're going to do is we're going to put an empty circle on the 2.8, right, for now. And because it's all of the numbers less than that, I'm going to just draw a straight line in the less than direction, like to the left. Because every single one of those numbers counts. The 2, the 1, the 0, the -1, the -2, the -3, the -4. But so do all the numbers in between them, and that's what the line is for. We're kind of saying it's not just the stopping points of the whole numbers, it's everything in between them. So that's what the line is for. Instead of just having to do a dot for every number, for 1.2 and 1.3 and 1.4 and 1.5, just do a line. Now, if you recall, the little equal symbol is under here, so that means you do fill this in, because filling it in just means you can use the 2.8 as well. If you can't, you would leave it empty. If it had been this, you would have just put a circle on 2.8 and left it. You would have done the line to the left, but you wouldn't have colored it in at all. Hopefully everyone kind of knows what I'm talking about when I say that. Yeah, hopefully that's not too bad, because I think that's kind of covered everything. I'm always wondering how, again, it makes sense to me, but again, I'm just kind of curious how much sense it makes to you guys. But look, if it's for the exam tomorrow, let's say in a couple of days, follow this logic. N and Z use dots, but only on the numbers they're allowed to from page 23 of your log tables. Or is a full line, and you do a full circle at the end point. If there's a little equals, you do an empty circle if there's not a little equals. Okay. Just because we're on the same track, I'm going to go back. These two are junior cert questions, but they're not as clean cut as the other one. That's just why I wanted to do the other one. It was a bit clean cut. I'm going to do honors, leaving cert honors afterwards, but like literally, like they make them deliberately more intense than anything else. So I don't think anyone from junior cert or ordinary level leaving cert will be able to do those ones. So I'm going to do these ones because they cover everybody first. If we look at the right hand side, just because we're using the graphs at the moment and we're just kind of handily, I'm going to bring it down here just because I have the N and the Z and stuff written down here already. Write down an inequality in X represented by each of the number lines shown below. Put a tick in the correct box in each case to show whether X is an element of N, Z, or, and the first one is done. Now, if I remember, there's multiple answers for these, so that's going to make things trickier. But for the first one, you'll notice they did a straight line. That immediately means OR, right? That's why the tick is in the OR box. For the first one, straight line means OR. And matter of fact, while we're on it, there's a straight line down here. So just put it, I'm going to put a tick in that box straight away. Straight away. You only use the line for OR, so that's that. The dots can be used for N or for Z, so I don't know that yet, so I'm still going to investigate that one further for the middle two. But for the first one, it was a straight line, so they said OR, and they said there's a full circle on the minus 3. So it must have been, there was a minus 3 with a little equals bit. I've covered it, but hopefully you can see what I'm pointing at there, that it would have at minus 3 is less than or equals to. And then you notice they did an empty circle, so they went, well, an empty circle means you don't do the little equals part. It's an endpoint, but you don't do a little equals part. Or you don't fill in the circle because there's not a little equals part. So what they're saying there is as long as you can put a number in for X that is both greater than or equal to minus 3 or that it's less than 2, it would be happy days. And that does make sense because you notice the line only covers numbers that you could put in there that it would make sense. For example, if you took this, let's say this is 1.3, if you put that in here, it would make sense. It's bigger than this guy and it's less than this guy. Happy days, right? Now, the second one, so it's dots, so it's either N or Z, but it includes negative numbers. So it has to be Z because N does not have any negative numbers in here. It's all positive, so we do not include them. So immediately that's Z. So now here's the thing. There's a couple of different answers we could do here. You'll notice they do minus 3, minus 2, minus 1, 0, 1. So the very basic, most basic answer would be minus 4 is less than X is less than 2. Because what you're saying is as long as you pick a number that goes for X in between minus 4 and 2, you will be fine. However, and there's not a lot of room, so I'm going to do it out here. Another suitable answer would be minus 3 is less than or equal to X, which is less than or equal to 1. Because you notice that's still the same thing. It's still saying as long as you pick in between minus 3 and 1 this time, but you're allowed to include the minus 3 and 1. Over here, the not having the little equals bit meant there wasn't a dot on the 2 and there wasn't a dot on the 4. If I had done an equals here and here, for example, those two red dots would have been included and therefore I would have been wrong. So that one is fine. That one is fine. You could have done a mixture of the two. Let's say you had like this. That one is okay because you can include the minus 3 but not include the 2, which is what the number line did. Or you could have the reverse, kind of the other way around, where you have, that's completely wrong. You have minus 4 is less than X, but you don't put a little equals because you can't use the minus 4. And then this way you would put a little equals if you were to do a 1 because you can use the 1. So there was 4 different potential answers for that one. This one is a mess because there are 8 answers, I'm going to say. Well, 6 maybe. Not 8. Yeah. Well, technically you could be a dick and do infinite if you want to be a dick. But we're not going to be a dick because maths is cool. But I would use a different color so that we know what's what. So what I'm going to do here is I'm going to say, oh, they're all whole numbers. So again, it's not or. They're all dots, so it's not or, is what I'm saying. Then I'm going to say, well, they're all positive whole numbers. So we could limit ourselves to just n. That's perfectly fine. So that's what I'm going to do. I'm going to say, this is just n. And then I'm going to say, as long as you pick numbers in between 0 and 4, you're fine. That's okay. But again, there's multiple answers because you could have done 0 is less than or equal. No. Don't listen to my lies. Well, that was the dick part, but I don't want to be a dick. So what you could do is you could do 1 is less than or equal to X is less than or equal to 3. And that makes sense because what you're kind of saying is you're saying as long as you stay in between 1 and 3, but you can also include 1 and 3 themselves, which you'll notice is true. And again, you could do like a variation. You can mix them and match them together because you can do the, like the left half of this one and the right half of this one, and that would be okay putting them together, and that's what I've just done. Or you could do the other mix and match kind of scenario, like so. Again, all four of those are fine. What I was saying earlier about there being more is because you could also do it for Z instead, and just all of those things would have counted as well. Every single one of them. No, I'm not going to because it's just easier, but I just want people to know that there's more than one way to do things. Oh, and then Z. I forgot about Z. Or not Z, the OR. I lied. What color will I do? Blue. Now, this is OR because we know it was a straight line. We did that already. Now, there's two empty circles. So that means, now this one, there will only be one way of answering it. Two empty circles, two inequalities with no equals parts. Done, right? X goes in the middle. And then it's -2 over here because that's the circle over here. And it's 4 over here because that's the empty circle over here. And what we're saying is as long as we pick a number in between, yeah, sure. As long as we pick a number in between -2 and 4, we are fine. But the little equals means we can't use the -2 or the 4, and that's what the empty circles represent also. So we're fine. We're good to go. We're good to go. I'm going to try this one. So it says graph it again, right? So that's fine. It's just in the reverse. This is normally the way they do it. That one where they did the number lines and they were like, oh, do the maths was weird, right? Normally it's here's the maths, put it on a number line. So, yeah, so you notice that it's OR, so we're going to use empty circles, full circles, and straight lines. Now, there's no equals here, so I'm putting an empty circle on -3. There is an equals here, so I'm putting a full circle on 2. Now, don't make your circles this big. I've made this quite clumsy, right? Don't do this. Like, try to make your circles like that. Do you know what I mean? Do it a bit more like that. I'm just taking the piss, I suppose. And then it's just a line in between the two of them. It's happy days. Then you're done. Dusted. Use algebra to solve the following inequality. Now, here's what fucks people up. This was actually a junior cert question, so junior cert ordinary I don't think would need to do this, but everyone else would need to do this. So there's two inequalities. What you have to do is do the first one being from the very start and keep going, and then you hit the second one and you go, oh, forget that, we're not going any further. Then for the next one, you start after the first inequality and you take this guy, and that's how you do it. Just split it up into the red and the blue that I have, right? So the red one, or the blue one, as far as I'm concerned, would be -7 is less than 8 minus 3g. But then I would have hit the second inequality, so I stop writing. And the red one is after the first inequality. So it would be 8 minus 3g is less than or equal to 11. Then we're just going to solve the maths out, right? And the thing you have to remember with inequalities is when you're doing them, as long as you don't, what was I going to say? Oh yeah, as long as you're not dividing by a minus number or multiplying by a minus number on both sides, everything is exactly the same as an equals. If, for example, you had 1 is less than 5, which is a correct statement, and you multiplied on both sides by -1, you'd have -1 is less than -5, which is not a correct statement. So if you multiply on both sides by a minus or divide on both sides by a minus, you have to turn the crocodile around. You have to think of it like you're multiplying the crocodile by -1 as well, and you're just swapping him around. You're throwing him backwards, you're inverting him. So, what you could even do down here is you could treat this like an equals. You could literally just write that again with just an equals here. Then do exactly what you would do. Like some people will bring this over here and make it a -8. Some people would write -8 on both sides. It's up to you. But it would be -15. Again, I'd probably do an algebra one, and you can kind of look at how you do it that way and just kind of follow on from there. You notice here I've -3g, so I'm going to divide by both sides by -3. Now remember that we're dividing both sides by a minus. I'm putting a star there so we remember that. This would be 5 and this would be g. So now what we do at the very end is we just revert it back to the inequality. So the crocodile was this way around, so it should be 5 is less than g. However, we did divide both sides by a minus number, so crocodile actually has to be the other way around. So we're saying the final answer for that blue inequality is 5 has to be greater than g. That's all. Now over here we're going to do the same shenanigans. I'm going to just write it as an equals again. And then I'm going to bring Now again, some people minus 8 from both sides. I'm going to bring it across and make it a minus. So you'd have 11 minus 8. 3. Oh look, we have minus 3g, so I'm going to divide both sides by minus 3 to get rid of it. We'd end up with g is equal to minus 1. And then we can revert it back to the inequality. So I'm literally just going to copy it the way it was. However, and I forgot to mention this, or highlight it, we did divide both sides by a minus number, so what I have to do is I actually have to flip that around the other way. We still include the equals because there was a little equals at the start, but that's how you do it. That's how you answer that question. I'm probably going to take a break here, I suppose, just getting too late. So we'll see how jarring it is for the rest of you to see me just tomorrow take over. Okay, guess who recorded 35 minutes of inequalities and didn't have the screen set correctly, so ended up just recording his folder file for his folders, whatever, the folders and the files, while he talked about inequalities for 35 minutes, right? It was me, in case you didn't guess. I don't know, I'm sure you all got it, right? Because you're all intelligent beings. So what I'm going to have to do is now I'm going to have to go through all the exact same goddamn things. Isn't that fun? Now again, there was a break. I did say this. You won't know that though. Where I went through the last day. I know it's the same video for you guys, but the last day I went through kind of how inequalities can show up in questions here and here. That it's not an actual inequalities questions, but they can use it as a way of kind of getting an idea across. Then I would have come down here and I would have shown you how to do the graphs on the number lines, and how for n and z we use fulls, or we just use dots. They're on page 23. The z or the or is everything, so you have to do a full line, and you do an empty or a full circle depending on the context. Then I came up here and did this one, where I split this one into two inequalities, where you split it up based on going up until the second inequality and then starting from the first inequality. And then you have two new questions and you just solve them both separately. And the key kind of thing we introduced there was the idea that if you divide both sides by minus, or if you look above, multiply both sides by minus, the crocodile has to turn around. That's hugely important. Here's more stuff that I did. You'll see that later on though. Yeah, don't you worry about it. I'm just checking. I think it worked. I swear to God, if I have just pictures of the fucking folders again, I'm going to lose it. But the whole idea here is, right, these are actual Leaving Cert ordinary level questions. I'm trying to remember what I actually said. I don't think there's something huge that I would have said that I'm not going to say now anyway, but I'm just, if you hear me hesitating, I'm just kind of thinking, what did I say the first time I did this? Okay, but it says find the smallest value of n that is an element of natural numbers, which we saw before in the number line ones, and natural numbers on page 23 will just be any positive whole numbers. And if you think about it, you could sub in a rake of numbers for n. Now, you can't see it here maybe, but I'm going to tell you that if you subbed in a million there for n, that thing would definitely be greater than n 0, so that's fine. If you subbed in 72, that would be greater than n, happy days, or 0, happy days. But they're asking for the smallest value of n. That is a natural number, but that would still suit this. So what we're going to do is I'm going to treat it like an equals for the moment, right? So I'm going to treat it just like I normally would with an equals. I'm going to write it out like that. One thing I'll point out is people don't like the 4 at the end, but because they're in brackets, you're just multiplying them. You could swap it around like that if you wanted to. And again, I said I was going to write an equals, but I didn't. So I guess I'm just full of lies today. Minus 254. If you multiply 4 into the bracket, you get 4n minus 4 equals to 0. Due to the like terms, you get 4n minus 258 equals to 0. And another thing that I did say this the first time. If you want to try it, we're just trying it out. I know it's a bit late now that I'm in the middle of this, but if you want to just try it yourself, pause the video, see if you can do it yourself. Because I know you all do it's so difficult to study maths, and I do get it to an extent that I understand that when you study maths, if you come across a question you can't do, you're obviously going to feel stupid and that you can't do it, and there's no point going for any further. But I also know, let's be honest, we're all going to use that as an excuse if it means we get out of studying. So, be honest with yourself and try try doing this. If there's anything that you're stuck with still, you can always get in contact with me anyway. You all know how to get in contact with me. But and then some people, sorry to highlight what I did here, I added, some people would add 258 to both sides. I know a lot of you also just move it across and make it a plus. Different people do different things there. Again, I said it earlier, but I'm not going to maybe harp on too much about that because that's more so to do with algebra rather than the inequality aspect. So I will do something else for that, I suppose. But if there's a number in front of the n, you divide both sides by that number to get it on its own. And you end up with n is equal to, I did this 64.5. And then I'm just going to change it back to the inequality symbol. So the crocodile was this way. Now, did I multiply or divide everything by a minus number? No. Here I divided everything by a plus number, but that's okay. So there was no dividing or multiplying the whole line by a minus number, so I do not need to turn the crocodile around. I can use the original one from the question. Now, if you want to use the crocodile the whole way down there as well, that's also fine, but I just know it freaks people out, so I tend to show you that you don't have to. Now, what is the smallest value of n that is a natural number that would also suit this is what the question is, because, you know, n being greater than 64.5 is great. What's the smallest number that is greater than 64.5? And it is just 65. Because again, as I said, 72 or a billion or whatever the hell I said, they would also work here because they are bigger than 64.5, but they want the smallest natural number that would work. So we can't actually use decimals. We couldn't say 64.6 or something. We couldn't say 64.5000001 because they are not natural numbers. And that is the answer for that type of question. Sometimes questions like that will come up as like a part D and maybe a long question in the Leaving Cert. And there's a relevance to the actual letter. I can't remember where I got these from though. There might be a relevance to this, but it might be like n is the amount of days, and this formula tells you how long you'd have to go before something, you know, is greater than 0. I don't know what the context for that might be. But just be warned, that can be like a part of a long question, or it could just be a short question on its own and just a standalone here, do this inequality. This one was definitely one of those where it was just, here's an inequality, do it. So I guess we're going to do it. What I would advise again is write it all out with an equals. Again, if you don't want to, if you know what you're doing, go for it. But for a lot of people, I know this is easier. Multiply 2 into the bracket as such. Now, I'm going to leave the minus 2x here, but make the 6 on the other side. Now, different people would do it different ways again, where you move it and make it a minus, or take away 6 from both sides. It's up to you guys, but you all should end up with this, no matter what way you did it. And then if there's a number in front of a letter, we're going to divide both sides by that number to get rid of it. And we'd end up with x on this side, because the minus 2 and the minus 2 cancel. And it's minus 1 over here. Now what I should have done is I should have highlighted that I'm dividing both sides by a minus number here. The reason being is, if you remember in inequalities, we have to make sure that if we divide or multiply both sides by a minus number, that when we reintroduce the crocodile, we can't do it the same way it was in the question. We have to do it the opposite way around, because it was dividing by a minus 2. And that is our answer to the maths part of it. Now we also have to do, now here I forgot to mention it. It says x is an element of OR. We need to show our solution on the number line below, and that was important for the number line. We didn't really need it for the maths, but it's just saying that x has to be greater than minus 1, so we have to be able to find a number that can go in place of the x, that this would make sense. So 7 would work, or a 23 would work, or a 0 would work, because if you put any of those numbers in place of the x in the final line that I have, that makes sense. You couldn't have minus 6, for example, because minus 6 is not greater than minus 1. Yeah, but the thing about it is, as I said, x is an element of OR, so that means we can include all the decimals and all the fractions and all that good stuff. So we can actually include minus 0.92 and minus 0.87 and minus 0.00023, all of that type of shite. So, hopefully you would remember, because I know it was like a couple of days ago I did this, but when I was doing the number lines, I would have said to you, if it's an OR, kind of use this as your endpoint. You put a circle on it. There's no little equals, so we're not going to fill in that circle. If there had been one of these, we would have filled in the circle, but there wasn't, so it's fine. And it says x has to be greater than minus 1, so that means the numbers like 0, 1, 2, 3, 4, 5. So we're just going to do a line out in this direction. Yup. And hopefully that's it. Hopefully I don't make any mistakes, because I was pretty sure I didn't make any mistakes on the last one. when I did it the first time, but like God knows how poorly things went or are about to go. Because I don't know, it's actually fierce annoying when you look back and the clip is just 35 minutes of your video folder, and you're just talking in the background. It's madness. Oh yeah. Now, okay. So what I'm about to do now is sorry. Okay. So okay, so now at this point, I'm trying to remember what order I did this in. At this point now, I think everything else is done, apart from the, again, don't worry about that shit. That's not supposed to be seen yet. You'll see it when I do it. Yeah. Um, I filmed it in three parts. I did the first bit all over here, then I did the second bit, and then I did the third bit, which is these two. So these guys I did do, but I didn't record them properly. So that's why this stuff, you'll see this weirdly at the end. You'll see me videoing or doing this out because that bit I videoed fine for some reason. But these, we're about to go into Leaving Cert Honor level. So there is no point of anybody other than Leaving Cert Honors level doing these questions. I just want to highlight that. Everything else we've done so far has been everybody, but now it is just Leaving Cert Honor level. So, if you're still here and you shouldn't be, that's on you. I've done my best. But the idea is the modulus bars. So in Leaving Cert Honors, there's generally 90+% of the time, as I said, there will be a quadratic in the inequality. However, for this one, or no, yeah, there will generally always be a quadratic in the inequality, and there's two main ways it can show up. It can either show up as a modulus, like the one I have here, or it can show up as a fractional or a rational inequality, like over here. And again, I just took these from the past like 6 years of the Leave Insert or so. So if you are looking for them, that's what they are, and that's, just so you know, they are relevant. So for the modulus bars, there's two ways of doing them with the modulus bars, as you would have seen when we're doing it in algebra. So what I'm going to do is I'm going to do it both ways, and you're going to see it both ways. I'm going to do it the way that they teach it first. Most people will do it this way, and if it is like a week or two out from your leaving cert, do not try to learn the other way, unless you're in a severely desperate scenario, because think you're not. It's probably better that you actually go with this, even if you don't like it as much. It's the cemented way of doing it. What you would normally do is you would write it out like so. Now you can write it with an equals here if you want, just to make it easier. But with modulus bars, generally people would square both sides like so. Squaring the thing on the left, now here's the thing, don't forget, it gets rid of the modulus bars, but it does not get rid of the squared. So we have to still actually do the squaring aspect of it. We just do not need to care about the modulus bars. Now I'm going to skip a few steps, but if you need to do them out, take your time. Do not try just rush, because that's what I'm doing. Because I do a lot of these and I'm tired of them. So again here, use the minus b. Use the minus b. I've been on this rant before, I know, but I don't know what order you're watching the videos in. You guys, the minus b is so much easier for you with your log tables and your calculator. The reason why the teachers ask you not to do it is just because they are so good at doing it. I can do it fairly fast because we had to learn how to do it that way when we were in school, and also we all do so much maths that it's just, even if your maths teachers are so young that their calculators were actually like yours, they still do so much maths. It's just quicker and easier for us to do it. The majority of people, though, I would advise to do the minus b instead of doing these brackets. Even though they say to you, oh dude, it's more sincere, or it's more correct, but like, not really. It's you don't get any extra marks for doing it this way. As far as I can tell, you guys are more likely to fuck it up. So please just do the minus b. I did it here though, just to save myself time. And now don't forget, those are the roots of the quadratic that we ended up with. So we ended up with a quadratic, and I did the minus b, or well, we're pretending we did the minus b to get the roots. And that means that this is where you draw your graph. It's an x squared, positive x squared, so that means it's a u shape. And that means that the roots are going to be here and here. The bigger root always has to be to the right. Now, a lot of you guys don't understand these questions, I found. But if you remember, imagine we had done the inequality symbol the whole time. This would be greater than or equals to. This would be greater than or equals to. This would be greater than or equals to. This would be greater than or equals to, because at no point did we divide everything by a minus or multiply everything by a minus number. So, what this is asking is, when is the quadratic greater than or equal to 0? But that's the same as saying, when is y greater than or equals to 0? So it's just asking what points on this graph would have a positive y value. And you notice it would be all the points up here and here. But we do not want to go down underneath the x-axis. That's the bad lands. We don't want to go in there. Now, it's easy for me to kind of highlight it by dotting those in, but it will go on forever. So some dickhead would be like, oh, so it doesn't go up here, but it does. I just didn't draw the diagram. Some people would be like, oh, so there's none in here between here and here, but they're like, they all count too. I just didn't want to draw them all. So to account for dickheads, what we're going to have to do is we're just going to say, look, dickhead, as long as you stick to the left of 2, you'll be fine. And as long as you stick to the right of 6, you'll be fine. So what we would do is we'd say, as long as x is less than 2, because if you think about it, any number on the x-axis that you put in here that is less than 2 would represent this line. That's all the values on the x-axis that would be smaller than 2. Or if you pick an x that is greater than 6, because that would account for all of the numbers on the x-axis that are to the right of 6. Now, was there little equals under the inequality? There was, so we're just going to throw a little equals here and a little equals here, and then you're done. That's the question. Done. What I did do is I did actually do it out on GeoGebra, just to make it look like a nicer thing for you. Oh my god. Hold on, let me just get rid of a couple of things now, because obviously they're from left over from before. Get rid of this. That's all okay for the moment. So you notice that this is just a better version of the graph. I drew in some of the points along the way. And then, so you notice that the graph is for the x squared. It's for the quadratic, so it is this guy that I have the arrow to. It's basically this guy, is the green line. All the points are put in as well. You'll notice that as long as we stay above the x-axis, as long as we stay above this blue line here, all the y values would have a positive value. Whereas underneath the blue line, that'll have a negative. And that's what this question is basically asking you. When it says, when is it greater than 0, they're saying, when will the y values be greater than 0? We're saying, as long as you pick a number to the left of 2, you'll be fine. Because let's say you pick even here, just doesn't have to be a whole number. It could be in between two numbers. If you draw a straight line up, you will get a positive value. On your y, it's like 8.5, you'll notice. Or if you pick the number to the right of the 6, let's say 8 and a bit, you'll notice that it is also positive. It looks like it's going to be like 14 and a bit, right? So positive. However, in between 2 and 6, you'd have to go down, and that's why there's a -3, a -4, a -3 is the y values. So that would not be cool. We don't want that. However, let's say hypothetically the entire question, let's say the very start, the crocodile had been the other way around and it was just like this instead. Everything we did here would be the same, all the way down to drawing the graph. However, we'd instead want the -3 and the -4 and the -3. So we'd want these green points. We'd want to know when is y less than or equal to 0. And that occurs here, 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 you know. All of these points would have a negative y value. So we'd have to say, oh, as long as you stay in between the 2 and the 6, that's when you're fine. Because you notice if you stay in between the 2 and the 6, you'd have to go down to get to the graph. So if the crocodile had been the other way around and it was saying, when is the y less than 0? And it was basically saying what points would have a y value of 0, you'd say all the points that consist of an x. Now I'm going to write it over here because I'm going to move that in a second. All the points that would consist of an x in between 2 and 6. Now, the way you represent that is slightly different. You put an x in between 2 and 6, just because that's what it is. Any number on the x-axis in between 2 and 6. And then which number is bigger? Out of the 6 and the 2, it is 6. So the crocodiles are both heading towards the 6. They both have to go in the same direction. That's imperative. You can't have one going one way and one going the other way. That just isn't, that's not nice. We don't like that. So they have to go the same way. The 6 is bigger, so they're both heading towards the 6. And we put a little equals on the bottom here and here. Because what we're saying is you have to pick a number for x that you could put in here that this would make sense, but also so that this would make sense. They both have to make sense. And that's why when we did these ones up here, they have to be two separate ones. They can't be one of these double-barreled ones because they're two separate lines on the graph. This one here was one like unified section, so we could do one unified inequality in the green here. The other one we had to do is two separate ones. Hopefully that's kind of okay to see it that way. I'm going to do it the other way now. I am afraid that I'm just going to be kind of glossing over some of this stuff because in my head I've done it already. Obviously, you guys have only just seen it for the first time. Me doing it, that is this video. So I'm just hoping that I haven't forgotten anything. Excuse me if I do have to go back and be like, oh, I forgot this. I've just never, I never really realized how annoying that is. I've heard people who make like YouTube videos and stuff say, oh, I recorded over footage or something. I never realized how annoying that was. But another way of doing modulus bars would be, instead of squaring both sides, you put the thing equal to the positive and to the negative of the thing on the other side, right? So you could write it like this. Again, I've chosen to do the equals instead of the inequalities just to make things clearer. And then you would bring the -4 across and make it a plus, and 2 plus 4 is 6. Here you bring it across and it become a plus, and -2 plus 4 is 2. You'll notice that that just brings me straight to these two numbers, so that's the same bit there. And you might go, Jesus, that's fucking faster, I'm going to do it that way. The problem is the graph afterwards is a shit show that you guys are not capable of really doing, it seems. Because for the modulus bars, don't forget that when you're graphing a modulus bar, if it was just x minus 4 on its own, that's not what I meant to write at all. If it was x minus 4 without the modulus bars, the way that's graphed is a straight line like this. It goes through the point 4, 0 on the x-axis, because if you subbed in 4 for the x, you get 4 minus 4, so the y value would be 0. That's why the point here is 4 on the x-axis, 0 on the y-axis. However, the modulus bars, if you recall, means, now there's more to it than this, but basically it means you can't have a minus. So what it does is it just mirror images that the underneath part, but it just swings it up to the top. And then this, let me change that. This part here isn't actually there. God, that's gonna. Oh, okay, that worked out a lot better than I thought. But that's what the graph would look like. And if you subbed in 5, you would get 5 minus 4, which is 1, so that would give you a height of 1. If you subbed in 6, you get 6 minus 4, that would give you a height of 2. I'm just subbing it into the original, into this guy, and just tell him whatever the answer is, I'm treating that as the y value. If I subbed in 7, it would be 7 minus 4, which is a height of 3. If I subbed in 3, I'd get 3 minus 4, which is minus 1. But don't forget, it has to be positive. Wow. 2, if you sub in 2, you get 2 minus 4, which is minus 2, but then it has to get to a height of plus 2 because we don't have the minuses. If it went to 1, we'd have to go up to 1 minus 4, which is minus 3. However, again, the minus is fucked off, so it's going to be plus 3. Now, the way we have to do the V graph is, you see the way it says when it's the modulus bars greater than or equal to 2, you have to draw a graph that is at a height of 2 on the y-axis. So this red line, I know it's not perfect, but that red thing would be on the, let's say this is the y-axis, it would be 2 here, right? I'm going to get rid of that because that was awful. But you'll notice that to answer the question, it's saying when is this graph greater than or equal to 2? And that kind of means when is the graph above the height of 2? And in the same way, as long as you stay to the left of 2 on the x-axis, you notice the v will be above the red line. And as long as you stay to the right of 6 on the x-axis, it will also be, the v will also be above the red line. So it's the exact same thing, because we'll be saying to the left of 2 on the number line is x is less than 2, because all the numbers on the x-axis to the left of 2 represent numbers that are smaller than 2. And over here it would be x is greater than 6, because again to the right of 6 represents all the numbers that are greater than 6. Yeah, on the number line. Sorry, I thought of something else. I thought I fucked up actually some of the other video thing, but I'll have to have a look. If it had been when is it greater than or less than, again, it would have been like this. When is the V shape below the 2? And you notice that's this part here and this part here. You notice they are below. That's not going to stick to a straight line, is it? Nope. That is when it is the V line is below. Oh, I want to go above, but look, it's not supposed to go. Oh, it just doesn't appear. I'm having a great day. But that's what it would be if it had been the crocodile the other way around. And we'd say, oh, as long as you're in between 2 and 6, and you do the X in between the 2, and 6 is bigger, so the crocodile's head that way, and you put the little equals on it because there's a little equals on the thing, and I forgot to do that for the red one. I realize now. I do apologize for anyone who's screaming at it. Anyway, just to highlight that as well, I also did do the graph on GeoGebra for the V shape as well, just so you could see that I wasn't talking pure shite. If you put in the x minus 4 in the modulus bars and the red and the blue circle, you notice the blue line represents that, hits the y-axis or the x-axis at 4, and then the y equals 2 is the horizontal line at a height of 2. When does it hit the when is the graph above a height of 2? As long as you go to the left of over here, but that means to the left of 2 on the x-axis, or as long as you go to the right over here, but that means to the right of 6 on the x-axis. Cool. I had fun when I did this the first time. Now I'm pissed. I'm just not. I never thought I'd be pissed looking at GeoGebra, which is a free app, by the way. Just putting that out there. You know. Yeah, I guess I'm just going to launch into another one now. And I will do it both ways. But again, I would advise you just to do it the left-hand side way, because that's the way the majority of people do it. If you happen to be watching this while you're in 5th year and you want to learn it the right way, that's not okay. That the right hand way, not the correct way. Before you're all getting a twist, by all means, go do it then if you want. But oh look, this is another question from the Leaving Cert in recent years. It is a modulus bars. Oh no, the 1 has snuck over here. Oh no, whatever shall we do? We will remedy it straight away by just rephrasing the question as the modulus of 2x plus 5 is less than or equal to plus 1. Just moving the 1 across. I forgot the modulus bars. And then again, if you do it this way, you'd square out the 2x plus 5. I might skip a couple of more lines this time if that's okay with you guys, because hopefully you'll have understood the method from the previous one. That you'll be able to follow what I'm doing here, even if you have to do a few more steps if you're writing it out, if you want to be sure and just be safe. But then you would have this. You could divide everything by 4 should you choose to, but at that point you could have just done the minus b formula, because you notice it was just an x squared and a number. And then, but if you were to do it this way, you'd get this. Yeah, I'd advise you to do, I know this looks easy when I'm doing it out and you've seen it and you go, oh yeah, that makes sense. But you have to remember, you'll be in your exam, you'll be stressed up to your eyeballs, and then you'll get something wrong. You won't think of the factors of 6, or they'll pick a number bigger than 6, or something will go wrong. So just use the minus b. Now I'm going to look at this quadratic, and I'm going to remember that the quadratic, or the inequality, was this way around originally in the question. I did not need to turn it around, because at no point did I divide or multiply by a minus number. So I'm going to go into the graphing part of it now. It's a positive x squared, so it's going to be a U shape. Here's my x-axis. It's at minus 2, minus 3. The smaller numbers on the left, bigger numbers on the right. They're saying when is the quadratic less than or equal to 0, but that is just code for when is y less than or equal to 0. So where on this graph would the y values of the points be negative? And you'll notice it's these points down here. So what I'm going to say is, as long as you pick a number for x that is in between minus 3 and minus 2, my good man, you'll be fine. The thing is, which number is bigger? The minus 2, so they're both going to head that way. And there was a little equals in the question, so I'm just going to slap a little equals on there. If you were to do it the other way, it would be 2x plus 5 is equal to 1. 2x plus 5 is equal to minus 1. Then 2x is equal to minus 4. 2x is equal to minus 6. X is equal to minus 2. X is equal to minus 3. Hopefully you all understand the algebra I did there to get there. And then what I do is I draw the V centered around. Now this one's going to be centered weirdly around minus 2.5, right? This is why people don't like doing this, because you'd have to sub in minus 2.5 in here, so that when you add it to the 5, you get 0, which is what you want for where the V touches the x-axis. What number you'd have to sub in to get 0 as an answer. So then the graph would look something weird like this shit. Like so. And you'd have to actually do the -2, the -1, the 0, kind of like what I was doing before. If you sub -2 everywhere you see an x, you get a height of 1. I put that there just to remind myself. If you put in -1, you get a height of 3. If you put in 0, you get a height of 5. And on the other side, then, if you did it for -3, -4, -5, it'd be the same thing. It's going to be a mirror image, but just to be sure, -3 into there would give you -6, plus 5 is -1, but then again, it's not going to be a minus, it's going to be a plus. -4 in there would give you -8, plus 5 is -3. But again, it's not going to be a minus. And then -5 in would give you -10 plus 5, but it's not going to be a minus, it's going to be 5. Now the question said, when will the quadratic, or when will the modulus be greater than or equal to 1? So I'm going to just draw a line at a height of 1. And it fits perfectly, you'll notice. It hits both of the points, dead on. But when will the quadratic be less than or equal to 1? Well, it's when the graph is here or here. So we have to say, as long as you stay in between -3 and -2 on the x-axis, you'll be fine. So like this. And then what we will say is, we'll say x is in the middle of -3 and -2. Which number is bigger than -2? So crocodiles about go that way. There's a little equals on the bottom of the thing. And there you go. That's it, done. Again, two different ways of doing it. I'd advise you just stick with the left way. Was there something else I was going to say? No, I don't think so. I suppose all I'll say is, if the quadratic, of course, had a minus in front of the x squared, it would be the exact same, be this though instead. So then if they had said, let's say it had been similar to this question, and they said, when is it less than 0? It would be all these points here, here, and here. You know what I mean? So it would be as long as you're to the left of here and to the right of here. It's kind of the opposite to what it was for this one, because it makes sense, because it's an opposite graph. It's upside down. So in this scenario, if literally it had just been like minus, it would have been upside down, and this would have been like -3 here, and this would have been -2, and we would have said as long as x is less than -3, or as long as x is greater than -2. So you notice it just goes in the opposite direction. Like, that's all that would happen. I think in honors leaving cert, you'll kind of be okay with being aware of that. I don't think any of these necessarily work out to be that. It could have happened if, for some god-forsaken reason, you see the way here I brought the 1 over and made it a -1, and I said 25 minus 1 is 24. Let's say hypothetically I took all 3 of these guys and moved them all over here and made them minus. Then the x squared would have been a minus, and I would have had to do the thing upside down. But the graph, it would have worked out to give me, now I know these ones were slightly different, but it would have, all the way the rest of the maths would have worked out is, I promise it would have worked out to give you the same answer anyway, so it doesn't actually matter. These aren't the proper answers in that regard. I just wanted to show you a vague idea of what the idea, it's just an N shape. Still the same logic applies of being above the axis or below the axis, and then to the left or to the right of that. That's all the same. That's all fine. Again, if there's an issue, you can always text me. It's grand. I'm a bit upset about the thing still. That's okay. Just having to do this again. So here, solve this equality. So this is the first inequality that is this the last one actually for the new? Okay, this might actually, okay, I'm a bit cheered up now. So this is the last one that I'm going to do here, and then I'll have to cut back to old Graham, and he will be oblivious to the fact that he is fucking up his recording, or had just fucked up his recording. So be nice to previous Graham, don't bully him. He won't know yet. And he'll be in a better mood. Solve this inequality. So now here's a fraction in an inequality, or otherwise known as a rational inequality. Rational being like the fancy maths way of saying a fraction. Now normally, if that had been an equals, normally what we would do is we would multiply, I'll do it down here. We'd have multiplied on both sides by x plus 2. We'd multiply it on this side by x plus 2, and we multiply it on this side by x plus 2, because then this and this would cancel. Happy days, and then you can just move on with your life. No, there's no moving on with your life, because the problem is, If in inequalities we end up multiplying by a minus number, we have to turn the crocodile around. However, x plus 2 can be both positive and negative, because let's say x is 10, then this would be 10 plus 2, which is 12. But let's say we do the exact same thing of x plus 2, but x is equal to minus 10. And then, then it's minus 10 plus 2, which is minus 8. So, x plus 2, it could be positive or negative depending on the circumstances. So, because it can be both, we can't actually do this this way, because we wouldn't know whether we're supposed to turn the crocodile around or not. We would only account for half of the scenarios. So instead, what we're going to do is we're going to pull some absolute shenanigans, because what we're going to do is we're going to multiply on both sides by x plus 2 squared. Because then we'd have 2x minus 3 on the top here. And then we'd have x plus 2 here. That's just this fraction here. We'd have the greater than or equal to, we'd have the 3, and then we'd have the x plus 2 squared on this side also. And the thing is, because this is squared, and because squared means there's two x plus 2 brackets there, I can get rid of the squared and the x plus 2, because then the squared, it doesn't mean there's two brackets, there's only one of them left, which makes sense. If it was cubed, you'd have to cancel that and break it down to a squared up here, because there'd still be two left. But because there's only one left, and I have a bracket written here, we're fine. So I'm just going to write that down now, a bit cleaner with the things chopped out that we cancelled. We're doing here and here. Now the thing on the right here, do not multiply the 3 into the bracket, please. Squared, BIMDAS means you have to do the power first. So on the left hand side, we're going to get 2x squared. We'd end up with plus x minus 6. Again, maybe do it out properly. Over here, we'd get x squared plus 4x plus 4. And then we get 2x squared plus x minus 6 greater than or equal to 3x squared plus 12x plus 12. Now you can bring everything to the right or to the left. I'm going to bring everything to the do you know what? I won't. Normally I'd bring everything to the right here, because then I'd know that it's going to be 3x squared minus 2x squared, and this would be a positive x squared, which is happy days because it'd be a U shape. However, while I advise that's what you should do in the event that you get this in the leaving cert, I will do it the other way, because I know some of you dumb fucks will do it the other way. So, let's say, I just have to be different. I'm doing it the other way, all right? And I'm going to move everything to the left. Then you notice it would be 2x squared minus 3x squared. It would be this plus x on the left minus this 12x. And it would be this minus 6 minus 12. It's greater than or equal to 0. I didn't do this the first time. I just, it'll change it up, because then we'll have minus x squared from these two. These two would have minus 11x. And these two would be minus 18. Now, let's say you got to this stage, right? If you hadn't done it, you would have had all the positive numbers on the other side, and you do the minus b, and you do your graph, and you'd be away. Here, you can just do the minus b formula, and your answers will still be, now I'm going to just tell you what they are, right? Your answers are minus 2, I think, and minus 9. Minus 2 and minus 9. Yes, I think that makes sense. Yeah, I think that makes sense. And then that's what you would get when you do your minus b, hopefully. You can do it and just check, but I'll probably have figured out by now, by the time you get to it, if I'd done something wrong. Now, if we were to just do the quadratic, right? This is the quadratic this time, and it's asking when is the quadratic greater than 0, so it's asking when is y greater than or equal to 0. But keep in mind, it's a minus x squared, so the graph will look like this. Here's your x-axis. The smaller root is on the left, as we always say, so that's minus 9, that's minus 2. Then what we would say is they want to know when is the y greater than or equal to 0, so I'm going to say, well, this point, for example, has a positive y, and so does this, and this, and this, and this, and this, and this, but not down here, and not down here. So we're going to say as long as you pick a number on the x-axis in between minus 2 and minus 9, you will be okay. So I'm going to put minus 9, and I'm going to put the x in between the minus 9 and the 2. Which number is bigger? The minus 2. Don't let that trick you, right? Because people will think, oh, well, 9 is bigger than 2, but it's a minus 9, it's a minus 2, so it's the reverse. They're the Wario and Waluigi of positive numbers. So the other thing is you'd say, oh, well, was there little equals under here? There was. So I'm going to put a little equals under here. But that's where you'd be wrong. That's where the maths will bitch slap you. You cannot put in this one simply because they've mentioned already that x cannot be minus 2. And it's a little dastardly thing they'll do, but you have to leave it like that, where you only put it on the minus 9 side. You don't put it on the minus 2 side, because x is not equal to minus 2 as mentioned in the question. And the reason why is because if you put in minus 2 into the original question up here, on the bottom, you'd end up with minus 2 plus 2 here, which would be 0. And you can never allow it that the maths ends up with a 0 on the bottom of the fraction. So that was just cheeky the way they did that. But hopefully you'll know what I did there. Hopefully I don't need to do it with the positive x squared. Hopefully you're all okay. Basically though, just be careful when you do it and you won't end up with a minus anyway, but I just wanted to show what you would do in that scenario. Okay, be careful with it. Don't mess it up. So that's everything that's there. I will, okay, yeah, so in the middle of this video, okay, no, don't worry about it, that's for me. I'll pass you on to previous Graham. Okay, so there was another break in the thing, and I didn't really expect it, so I'm sorry if it's very jarring what you're seeing right now. I know the camera probably jumped. Sorry, I don't know, I wasn't really expecting it, and it's been like 45 minutes, so I don't remember what I was doing. So I did the 3 basic versions of the minus or the inequalities that you're going to see in Leaving Cert Honors, where it's going to always end up as a quadratic, as I said. Now there might be the rare case where it doesn't. Like, don't come back to me and say you always said. What I'm warning you is, like, expect it. It's going to happen like 90+% of the time. So we did 3 right here, where we did 2. These are the ones I just looked through the past like 6 years of the Leaving Cert. These are the ones that showed up in the honors level 1. There was two modulus ones, and then there was a rational one with a fraction. But then there's also these 2, which it doesn't have to show up as a rational or as a modulus, but those are the ones that will show up in a short question as like like it might be like question 3A of paper 1, and it'll just say, oh, here's an inequality, do it, right? That's how they'll show up there. Sometimes it can show up in these questions, because the 2 questions I pulled here and here, you'll notice, are calculus based, because they both have f dash and g dash x in them. If you can't remember calculus, there's a video on calculus, so I won't go too hard into it. But the idea is, here's a function, and I left out part I, which is was the factor theorem, so I just left that out because there's no need for me to really do it here, I don't feel like, so I'm just going to launch into this. Part 2. So f dash x, first off, I'm going to figure out what f dash x actually is first off, and again, I'm not going to do too detailed an explanation on it, but it would be this. Now, because it says is negative, if you think about it, is negative means less than 0, and the way we'd mathematically write less than 0 is an inequality symbol, and that's how the inequality comes into it. It's a quadratic again, like I warned you. So if to be honest, if they did it one where there wasn't a quadratic, it would be that the rest of the question is going to be really hard and it's going to try wreck you. So just kind of take that into account. Be warned, it can happen, but it's kind of almost a warning, to be honest, rather than anything else. Now, I was also bitching and moaning and whining about you guys using the minus b formula, and I was going to use the brackets. You'll notice in this one it says correct to 2 decimal places. If you remember from junior cert, that means you have to use the minus b. There is no way that you can use the brackets. However, I am just going to half all of these just to show you that you could do that. It makes no difference though. If you did the first line or the second line in the minus b, it's fine. But it just means that you'll have minus 21 as the b in the minus b. I'm not going to write out the whole minus b if that's okay with you guys. Hang on, 21, and then it's going to be 21. Yeah, you'd put that in, you do the plus minus, you do the square root of, and then you'd have minus 21 squared minus 4 times 3 times 20, all over 2 times 3. You type it in once with the plus and once with the minus, and your 2 values for x would be 5. Now correct to 2 decimal places, hopefully you're all okay with rounding. 5.86, And then you do it again with the minus. Let me just make sure, because I've done this before. Oh yeah, I wouldn't have remembered that. 1.14, right? So those are your two values for x if you use the minus b formula. Now, it's weird. It looks weird because they're decimals. That's understandable if people are going to be weirded out by that. But it's the exact same concept where they were saying, when is this quadratic less than 0? Well, that means when on the u shape, because it's a u shape, because it's a positive x squared, when is that going to be below the x-axis? Here's your x-axis. Now here's your thing. Your two roots are 1.14 and 5.86. Bigger number on the right, though, don't forget. That's 1.14. And then it's saying when is it less than 0? So again, that means when would its points have a negative y value? And you notice it's all on this wonderful part down here. So we'd say as long as you're in between on the x-axis, in between those two numbers, you're fine. So you would say 1.14, you'd say x, you'd say 5.86, and the crocodiles would both be heading towards 5.86 because it's bigger. Was there little equals here? No, so we're not going to do little equals. And that would be the answer. Now, I remembered why this is. I did this recently with someone, but basically what that really means is, I won't put it in the graphing app. That's too pointy. I won't put it in the graphing app, but when you do it, it kind of looks like a cubic like this, and the x-axis is like here or something, and the y-axis is, or the y-axis, the other way around, sorry, x-axis, y-axis are like here and here. And what happens is, boom, 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 this one would be 1.14, and then under here, I should do it like here and here. Under here would be 5.86. And just to kind of explain what the question actually meant, to show that f dash x is negative, don't forget f dash x is the slope. So what it's kind of saying is show what values of x would the slope be negative. And that kind of makes sense on the graph if you think about it, because the slope means that it's just going down. And it does go down in between 1.14 and 5.86 on the x-axis. Just to give you context to the question. You do not need to do that last bit there. For this question, I just wanted to explain what's actually happening rather than it just being, here's a load of words and numbers and do this because I said so. Hopefully you can all see that it's just asking you, when is the slope negative? The slope is negative when it goes down. Oh, the graph does decrease in between those two numbers. Happy days. But as I said, I won't spend too much longer on that. The derivative of this can be expressed in this form. Find the value of a, b, and c. That's a different question again. I left that one in. I didn't cut that one out. I'm going to skip it though because it says if gx, okay, well I do need to know what f that, I'll do it here anyway. If gx is 36x plus 5, find the range of values for which f dash x is greater than g dash x. So what that's actually going to mean is on the graph, we would have like gx, well gx is going to be a straight line, so that's silly. We'd have gx here, and we'd have fx would be quadratic, let's say like here, and it's saying when is f dash x greater than g dash x. So what that's saying is on the graph, when is the slope of the blue line greater than the slope of the red line? Just to give you again context, it's not something that you'd be able to just figure out by looking at it, but I always like you to know what's actually going on rather than just me saying do this because I said so. But f dash x, given that they've given me x up the top, it would be 6x squared plus 12x minus 12. G dash x would be 36, and hopefully again you can know how to do that from the calculus. And then all we're going to do is when it says f dash x is greater than g dash x, it just means take this guy and put it greater than this guy. Oh look, it's a quadratic in terms of fucking inequalities again. Bring the 36 over, make it a minus. So you'd end up with this. So that's your question. I'm going to divide everything by 6 just to make it easier on me. You don't have to if you're using the minus b, so it's fine. Was I going to say something else there? Oh yeah, you can only do it here because we have an inequality or an equals. Do not, for the love of God, do it there because you can't divide both sides by 6, or else it would be f dash x over 6, which is just atrocious. So you can't do it unless you're at this point where you have an equals or an inequality in that, for that matter. Now this one is going to be x plus 4, x minus 2. I hope I haven't made a mistake, but if I have, hopefully your Yeah, okay, you can bully me for it. That's fair. I know you're going to text me like, you made a mistake, you fucked up. But hopefully, with regards to you guys doing the actual maths, you'll be able to see, regardless of my numerical error or whatever, how to do the question, right? I know, look, I know you're gonna, if I do make a mistake, you're gonna let me hear it, right? And that's fair. I understand. But I'm just letting you know. Hopefully, it doesn't disrupt your education. I guess it's weird to state anything that I do as education, but I guess that's what it is. So that's a quadratic. It's asking when is it greater than 0. It's a positive x squared. Positive x squared means a U shape. Here's your x-axis. The roots were 2 and minus 4, the smaller number being on the left. So that's there, that's there. It says when is it greater than 0? When is it above the x-axis? When does the when do the points have a positive y component? It's all these points along here, here, and here. So as long as you stick to the left of minus 4, so as long as you pick a number on the x-axis that is less than minus 4, as long as you stick to the right of the 2, so as long as you pick a number that can go in place of the x there, so that it's greater than 2. Happy days. Everybody's so happy. Everybody loves inequalities, except the real life ones. So, okay, I think that's it. The only last point I'm going to make is for the quadratics. Every single one you notice that we've done has been a U shape. Yeah, U shape, U shape, U shape, U shape, U shape, U shape. If you do end up with a minus in front of it, the only difference is that before you decide the thing, like let's say this had been minus x squared, everything then would just be like this. The x-axis would be like this. This would be the minus 4. This would be the 2. And then if it said greater than 0, it says when is it above the x-axis. So it's still, now it would be here, right? It's still above, but you notice it's in the middle as opposed to the left and to the right. So what you have to say is as long as the x is in between minus 4 and 2. It's the exact same, just kind of topsy-turvy. Yeah, so the exact same, but the polar opposite. And then they're both heading towards the 2. Was there an equals on the thing? No, there wasn't, so there's no equals there. That would be if it had been a minus x squared. Just to make that point, I think that's all about inequalities. Yeah, hope you had fun.